Hey guys, what's up everyone? How are you people doing? Hoping that all of you guys are doing good and taking good care of yourself. My name is Anoop. Once again, welcome to today's session. This is Vedantu, 9th and 10th English channel. So today we'll be starting off with one of the chapters of CBSE 10th, that is electricity, where we'll be talking about all the topics of electricity. We'll be starting off with current and potential difference, one of the two basic topics of this particular chapter. So we'll be starting off with that. And as the days progress, we'll be understanding all the other concepts as well. So once again, people, welcome, and hopefully you guys will enjoy today's session. All right, so this is lecture number 1, where we'll be talking about current and potential difference. But yes guys, as the days goes by, like I told you, we'll be talking about Ohm's law, resistance and factors affecting resistance, resistance in series and parallel, resistance in parallel, we'll understand about that as well, heating effect of electric current and electric power and energy, and we'll also solve some numericals based on it. But before we get into all of that, let me start off this session also with a quote, and this quote is a very peculiar one. Here's the quote, guys. The capacity to learn is a gift. The ability to learn is a skill. The willingness to learn is a choice. And this was said by Brian Herbert, who was actually an American, he was a writer, author. So he was the one who said this. And it's a very beautiful quote from the time. I mean, you can clearly read it that it's a beautiful quote which tells us that not everything in life is something that you can take for granted. There are a lot of people out there who are struggling to do what you're doing, so you guys are in the lucky bunch, I would say. Anyways, with that said guys, let us get started with the first concept for today, which is nothing but current and potential difference. So we'll start off with this, and like I told you, we'll be doing the rest of it as we go ahead as well. So let's start off with current, electric current. Now you guys already are well aware of how to define current. So if you were to ask any 10th grader by now, so you would have been an expert in explaining this. What is current? Current is nothing but the rate of flow of electrons in a conductor. That is what is called as current. So the rate of flow of electrons in a conductor is what is called as current. So if you have to define that, if you were to ask why electrons flow freely, because obviously it is the free electrons that are moving inside the conductor. So the question is, why do electrons flow freely in a conductor, right? You would have all wondered this, and by now you would have had the answer for this question as well. Like you have probably studied this in your chemistry, that when you talk about conductors, the peculiar thing about conductors, the major difference between conductors and insulators are this: conductors have a lot of free electrons. Now what are these free electrons? See guys, there are, you know about the electronic configuration, right? For example, if you talk about any like let's say, let's take the example of copper, which is one of the best conductors out there. So copper has an atomic number of 29. So the atomic number of copper is 29. So if you were to show the electronic configuration, you see that there's one electron in the valence shell. All right, so basically this is the electron that is free to move. So because it has the distance from the nucleus to this valence shell is more, even if we give a little bit of energy, it can easily come out of that valence shell and basically roam around freely. So that is what is called as a free electron. So in copper, every atom you will get one free electron. So for every atom there is one free electron. That means how many ever number of atoms are present in a conductor, that many number of free electrons are also present. Now here's the thing guys, in insulators we don't have those free electrons. Electrons are basically forming bonds between two other atoms, so there are no free electrons. But in conductors you have a lot of free electrons, and that is the reason why conductors are able to conduct heat as well as electricity. Now we are not concerned with heat, we'll be focusing more on electricity, but yes, free electrons are the reasons why metals are good conductors of heat as well as electricity. The free electrons, again, what are those? They are basically the electrons which have come out of the valence shell and are basically free to move without any kind of bondage, and that is what is called as a free electron. Now here's the thing guys, when you connect, like let's say this is a current carrying conductor, let's say that I connect it to a battery. All right, so the battery is like, let's say that this is the negative terminal, this is the positive terminal. All right, so I've connected this, this is the conductor, current carrying conductor, and that is the cell that I've connected it to. So this is the negative terminal and this is the positive terminal. Awesome. Now here's what happens guys, when you connect the conductor to a cell or a battery, what happens is that the electrons, the free electrons, start moving or flowing from one end to another. So they basically start flowing from the negative terminal to the positive terminal, never the other way around. Electrons are moving from negative terminal to positive terminal. Why that? Because negative terminal of the battery has a lot of free electrons, so basically they are pushed from the negative terminal to the positive terminal. Now, when the electrons are moving from negative to positive terminal, when you say the current would be in the opposite direction. Because I'll tell you the reason for it, but remember this, guys, electrons are moving from negative to positive, but then the current, when you show it as the opposite direction, that is positive to negative. So when you say current, it is always in the opposite direction to the flow of electrons. So whatever is the direction of the flow of the electrons, it'll be just the opposite to that. So the current would be just the opposite to that. Always remember this, guys. Now the reason is this. Here's the thing, guys. For a very long time, we did not know the existence of electrons. In fact, the existence of electrons were discovered by J.J. Thomson in the year around 1897, if I'm not wrong. Sorry, around 1890. So it was very, very recent comparatively, because we've been doing, experiments on electricity for a very, very long time. And for a very long time, we did not know that electrons are the ones who are actually conducting the current, or the flow of electrons is what is current. We did not know about that for a very, very long time. In fact, it was Benjamin Franklin who was the first person to actually say that it is the electrons, or there are negatively charged matter called as electrons, which is actually responsible for the flow. But then that was in the 1700s. For almost 150 years and all, we still continue to believe that the flow of charge is actually from positive to negative. So we always believe that it's actually from positive to negative. So we always believe that it's always from positive, because everything we've taken as, like, for example, if we talk about heat flows from object which is hot to a colder objects. So if you talk about wind, also high pressure to low pressure. So everything that we know, all the concepts that we know, is always considered from high to low. So technically we took positive to be higher, so we thought that even current flow also happens from positive to negative. But then it was proved wrong later on. But the problem was that we had already done so many experiments, and changing it would have been a very expensive thing, and so people just kept it as it is. Like, it's like, for example, in India, we drive on the left hand side, right? All the cars we drive on the left hand side. If tomorrow the Indian government tells you to start driving on the right hand side, that would be a very confusing thing, because people are not used to it, especially in India. Maybe other parts of the country, whoever is driving in the right hand side, if the government tells them to start riding in the left hand side, that would be super confusing, right? So to avoid these kind of confusions, we kept it as it is, and that's why it is called as the conventional current flow. So what is the conventional current flow? Is nothing but, we still consider, whenever we do an experiment, when you show the flow of current also, we show it from positive terminal to the negative terminal. But that is not the truth, because current is what? The flow of electrons, and electrons are flowing from negative terminal to the positive terminal. So the actual current flow is from negative terminal to positive terminal, but in the conventional current flow, we take it as positive to negative to avoid confusion, because a lot of experiments were done before that, and the scientists just couldn't do it. They were too lazy to change it, so that's how it is. All right, anyways, so that is the conventional current. It's not that they were lazy, it's just that it was too much work. They had to redo all the experiments and reprove everything. So to avoid all of that, they went with the conventional current. All right, now here's the thing, guys. So the formula for current flow. So electric current is basically what? The flow of current per unit time. So basically, I here is current, Q is the charge, and T is the time taken. So you represent it as I is equal to Q by T, where this formula you can use this formula to calculate the current. So let's say that there is, let's say 10 coulomb of charge passing per second. Then you can say that the current is 10 coulomb per second, which is called as ampere. So the SI unit of current is ampere, which is nothing but coulomb per second. The SI unit of charge is coulomb, and the SI unit of time is second. So coulomb per second is what is called as ampere, which you guys are well aware of. This is one of the very first thing that is shown in your CBSE textbook. So I'm pretty sure that you guys are well aware of it by now. So current is what? the flow of current, the flow of charge, the rate of flow of charge is what is called as current. So here current is I, so charge is Q, so I is equal to Q by T, which is what is called as ampere. Now here's the thing, guys. Now if the current is, so I already told you that the conventional current is, we take it from positive to negative, so that is called as positive charge, so that is called as positive current. Now there is nothing called as positive and negative current. First of all, let me tell you that, because current is not a vector quantity, it is a scalar quantity. It does not depend on the direction. But the thing is that when you talk about current, the important thing is that, like I told you, that it is actually the flow of electrons, and electrons are flowing from negative terminal to the positive terminal. So if the electrons are flowing from negative to positive, it is considered to be positive current. That is the prescribed path from negative to positive, which means that the conventional current is positive to negative. And if the ions are moving, that is, see guys, if you talk about, let's say, you know that salt water is a good conductor, right? So salt is basically NaCl. So when you mix salt in water and you pass current to it, what will happen? Because of electrolysis, Na will become Na plus, and then we'll have Cn minus. So if the ions, the positive ions, are the ones responsible for the flow of current, then it's called as positive current. If the negative ones are responsible for the flow of current, it is called as negative current. That's the, so if you talk about ions, that's how it is. But if you talk about if you talk about a conductor, it has the metal ions. So the metal ions, if they are the ones conducting it, it is positive. If it's the other way around, then it's called as negative current. But then again, like I told you, there is no positive negative current. It is just that who are the ones correct. Is it the minority which is carrying the current, or is it the majority which is conducting the current? That is all that matters over here. But then again, there's no negative and positive, just to clarify that. Anyways, so here's the thing, guys. To measure current, we use a device called as an ammeter. Ammeter is the device that is used to measure current. So you have all the measurements are in terms of ampere. So whatever is the current passing through the conductor, if you connect this, you'll be able to find out the current passing through it. And this particular ammeter has very less resistance, so it's generally connected in series to the what to say, when you have a conductor, when you have a electric circuit, it's connected in series. Whereas if you talk about potentiometer, or if you talk about not potentiometer, if you talk about voltmeter, it is conductor in parallel. I'll talk about voltmeter as we go ahead, but for ammeter, it is conducted in series, that is one after another. It is connected to find out how much current is passing through the conductor. As simple as that. Alright guys, so with that said, let's do some Q&A questions now. Let's do some questions now, and in the meantime, again guys, when I'm doing the questions, I want you guys to try it out as well. So take a piece of paper and a pen and write down the answer. It's mostly MCQ questions, so you don't have to really write 2 mark 5 mark questions, and just pause the video for a second, tell whatever is the answer to yourself, and try to solve it by yourself. All right, so here's the question, people. Here's the question: when do we say that electric current is 1 ampere? When do we say that electric current is 1 ampere? Option A, 1 coulomb flows for 1 second, 1 electron flows for 1 second, 1 proton flows for 1 second, or none of these. When do we say that electric current is 1 ampere? Okay, I'm not gonna give you 10 seconds. Tell me what the answer is, guys. Okay, so the answer to this question is actually option number A. The reason is because we know that current, that is I, is equal to Q by T. So basically, it's the number of the number of charges passing per 1 second, the rate of flow of charge, in other words. So how many coulombs of charge is passing in 1 second would give you the current. So that is 1 ampere current is equal to how many coulombs are passing in 1 second time. All right, now or 1 coulomb of charge passing through in 1 second time is what is called as 1 ampere current. All right, next question, guys. Here we go. It takes 2 seconds for a charge of 4 coulombs to flow in a circuit. What will be the magnitude of the current in the circuit? So that the time taken is 2 seconds, and the charge is 4 coulombs of passing in a particular point. There are 4 coulombs of charge passing through a point in 2 second time. You have to find out what is the magnitude of the current passing through the circuit. Is it 1 ampere, 2 ampere, 3 ampere, or 4 ampere? Again, guys, it's direct question. So I is equal to Q by T. Here Q is basically 4 coulombs, and time taken is 2 seconds. So 2 2s are 4. So that'll be 2 coulomb per second, which is also 2 ampere. That's all. So that is the answer, guys. All right. Oh my god. Okay. So ampere is the right answer. All right. I don't know what happened over there. All right. So the right answer is 2 ampere. I don't know, something went wrong. All right. ampere is the right answer. That's it. As simple as that. Direct substitution and you'll get the answer. The right answer is 2 ampere. Simple. Direct question. There's no confusion right there. Alright, here's the next one. A device needs 4 ampere of current to operate. If that device was operated for 10 seconds, find the amount of charge transferred. You're supposed to find out the value of Q here. They've given you the current and they've also given you the time taken. Is it 10 coulomb, 20 coulomb, 30 coulomb, or 40 coulomb? 4 amperes of current is passing through that, or you need 4 amperes of current to operate it, and you've turned it on for 10 seconds. You're supposed to find out what is the amount of charge transferred. Once again, guys, pause the video and try to do it by yourself. But in the meantime, I'll try to solve it for you guys. So Q is equal to if we talk about Q, it'll be 1 second, guys. Sorry, there's a small confusion. 1 second. Let me erase that out. So let me write the first formula, then we'll rearrange it. So I is equal to Q by T. So if you want to find out Q, Q is equal to I into T. Simple as that. All right. So I'll just put the values over here. We have 4 amperes of current. Time taken is 10 seconds. So I'll get it as 40. Basically, that we'll just write it as coulomb itself, 40 coulombs. That'll be the answer for this question. All right. So direct substitution, guys. So you'll get us 40 coulombs again. Here I have to rearrange the equation to get Q. So Q is equal to current into time. So current is 4 amperes, time taken is 10 seconds, you get us 40 coulombs. Simple as that, all right? Now that you've understood a couple of things about electric current, let's talk about electric potential. So let's talk about this, guys. It's actually a very simple concept. Now here we go. Let's say there are 2 containers which are connected by a link, all right, a small little pipe. So here's what happens. In both the cases, the water would flow from the first container to the second container. In both the cases, it flows from because if you look at it, the first container, it's very obvious that there is no water at all. So water would flow from the first container to the second container. But in the second container, it has some amount of water, but still, because the amount of water in the first container is more. All right, let me just go back to that. Still working it out, guys. 1 second. All right. Still figuring out all these tech issues. All right, anyways, so here we go. So in the first container here, because the water level is greater than the second container, you can see that the water would flow from the first container to the second container. Now, why does this happen? Very simple. It's because of pressure difference. Because in both the cases, container number 1 has a greater pressure compared to container number 2. And just like air, water also moves from high pressure to low pressure. Basically everything, or pretty much everything, goes from, like if we talk about heat also, high to low. If we talk about wind, high pressure to low pressure. Water also moves from high pressure to low pressure. So because there's a pressure difference, there's flow of water happening. Now here's the thing. This will continue to happen until both of them have the same level of water. If you look at this, if you look at the GIF, you can see that it will continue to flow until both of them have the same level of water. So here also, only if there's a potential or if there's a difference created, only then the flow of current would happen. Now, what I'm going to do is that we're going to understand what is that. All right, let's say that there's a plate. All right, there's a plate A, which has a lot of positive charged particle. All right, and let's say there's another positively charged particle which is at a distance. All right, it's far away, that there is no repulsive force acting on it, because obviously positive you'll have repulsion and negative positive will have attraction. So here it's a positive charge, but then the charge B that is there is pretty far away, so it has the charges on this plate has no effect on it whatsoever. There's no effect on it whatsoever. Now if I have to move that, I have to do some work. So I have to move that charge from B to a point where it can have some sort of effect, or if I want to bring it closer, I have to do some work. This work done to move that unit positive charge, or that one positive charge, from infinity, because I did not know where point B was, to a specific point, that is what is called as electric potential. Once again, guys, the work done to move a positive charge from infinity to a specified point, or to a specific point, is what is called as electric. That work done is what is called as electric potential. Now here, the work done is done by electricity. That's why it's called as electric potential. Now, let's say, guys, that the same charge, if I have to bring, let's say that I want to bring it to this point first, and then again I want to bring it to this point. So obviously, to bring it from infinity to this point, I have to do some work. Obviously, I have to do some work. Now, at the same time, if I want to bring it from infinity to this point, I have to do some more work. Now, obviously, there should be some sort of difference. There'll be some sort of difference in work done in both the cases. So this difference in work done in the first case scenario and the second case scenario is what is called as electric potential difference. So the difference between the work done to bring a point charge from infinity to a point, and then that is the difference between the work done between, again, to bring that point, the charge from infinity to another point. What is the difference between that work done is what is called as electric potential. Now, here's the thing, guys. If you talk about electric potential, the SI unit, because it is, again, you're doing a work, so basically work done is joules. The SI unit of work done is joule, and the SI unit of the charge is coulomb, so it's joules per coulomb, which is also written as volt. So basically the SI unit of this potential difference is volt. And remember this, guys, when you talk about potential difference, basically the current or the flow of current always happens from higher potential to lower potential, never the other way around. Just like how wind flows from high pressure to low pressure regions, in the same way current also flows from higher potential to lower potential, just like that. And this is why, because of this potential difference itself, the current starts flowing. So when you connect a battery, what are you doing? You're actually creating this potential difference so that the current starts flowing. That's why you have this 5-volt battery. That's why you have this 1.5-volt battery. That voltage represents what is the potential difference you're creating between the two ends so that the current starts flowing. So that is what the whole point of having a battery is. It's not like it's not some sort of magic. It is just that you're creating a potential difference so that the current starts flowing. So if you talk about the definition, potential difference is the work done to move a unit charge from one point to another. That is what I told you about. And if you have to talk about the formula, V is basically the potential difference, and like I told you, work done on a unit charge. So work done is W, and Q is basically the charge. So I'll just change the color of the pen. So yeah, work done is W, and Q is basically the charge. So work done on the charge. So V is equal to W by Q, where the SI unit is, again, if you talk about the units, it is joules per coulomb, which is what is written as volt. So the SI unit of potential difference is volt, and it is the device that is used to measure voltage can be two. You have something called as a potentiometer, and you also have something called as voltmeter. So there's a little difference between voltmeter and potentiometer. Voltmeter is used to define or used to find out the potential difference between 2 points. So you choose 2 points, and if you want to find out the potential difference, you use a voltmeter. But potentiometer finds out the EMF of the battery, because there's a lot of loss happening. And more importantly, if we talk about voltmeter, it has a lot of resistance. So you always connect a voltmeter in parallel because of the resistance. So if you use a potentiometer, the resistance is very less, and it can basically measure the EMF, that is the electromotive force of the battery itself. Using a voltmeter, you can't do that, but using a potentiometer, you can also find out the EMF of the battery. Alright guys, so that pretty much concludes the topic for the day. We'll do some questions now, and hopefully you guys did understand everything. Now, whatever doubts you have, anything that you have, I'll give you my email ID, and whatever queries that you have, you can also drop it down in the comment section below. I'll try to find some time to answer that as well. All right, so that's it, guys. Let's do some question answers right now, and let's see if you guys have understood everything so far. So people, here's the first question. What makes electric charge flow? Potential difference, pressure difference, height difference, or none of these? Which of these makes the electric charge flow? You have 10 seconds starting right now. So think it through, and then I'll tell the answer. But yes, I want you guys to pause the video and then try to find out the answer by yourself. Write down on a sheet of paper A, B, C, or D. It will hardly take you maybe a minute, not even a minute. It'll hardly take you 10 seconds. So let me know what is the answer. All right, in 5, 4, 3, 2, 1. The answer, guys, is actually potential difference, because yes, that potential difference that you create between two ends is what makes the charge to flow. As simple as that. All right. Next question. To move 10 coulomb of charge one point to the other, 30 joules of work needs to be done. Find the potential difference in the 2 points. Is it 1.5 volt, 3 volt, 4.5 volt, or 6 volt? Again, guys, pause the video, try to find out by yourself. I'll tell you what the answer is in a second. All right. So here we go. So they've given the charge is 10 coulomb. They've given the work done is 30 joules. So we know that voltage or potential difference is equal to it's capital V. Sorry, it's capital V. Potential difference is equal to work done divided by charge. So work done is 30 joules divided by the charge is 10 coulomb. So you'll get it as 3 joules per coulomb, which is equal to 3 volt. So the answer to this question is very straightforward. It'll be 3 volt, as simple as that. So just remember these formulas, guys. First thing, remember the formula of current. I'll just write that over here. Current is equal to charge per unit time, the rate of flow of charge, so Q by T, that is for current. And for voltage, remember this formula where potential difference is equal to work done by charge. So remember these two formulas. It'll come in handy because yes, you'll be using a lot of these kind of formulas in your exams as well. So try to take a piece of paper, use some color papers, color pencils if you have. Draw, I mean not draw in the sense, like write down these formulas in different colors and stick it somewhere that you can see. So when you look at it, you try to, because of the this is what is called as pictographic memory. Like for example, if I ask you what is the color of your toothbrush, you'll be able to say it immediately because you're looking at it every single day. It's not like you want to remember it, but you still end up remembering it because you're looking at it every single day. So same goes over here also. If you keep looking at it, even if you end up forgetting the formula in the exam hall, but because of your looking at it once, like again and again, you'll be able to remember the formula. So try to do it. It worked out for me in my 10th standard. Hopefully it works out for you as well. So do try it out as well. All right, here's the next question. Calculate the electrical energy produced in 5 minutes when a current of 2 ampere is sent through a conductor by a potential difference of 500 volt. So they've given you have to find out the electrical energy. The time given is in 5 minutes. The current flowing through the conductor is 2 ampere and the potential difference is 500 volt. So is it 900 joules, 300 kilojoules, 600 kilojoules, or 90 kilojoules? Now I'm pretty sure that many of you guys may be wondering, sir, how do we calculate this? So let me just show you how it's done. All right, you guys can also try it out. So first of all, electrical energy is equal to power into time. Electrical energy is equal to power into time. So power in terms of electricity is potential difference into current into time. So power is equal to basically P is equal to V into I. All right, that is what it is. Now put on the values over here. So voltage is 500, current is 2, and time taken is 5 minutes. So what I'm going to do is that I'm going to convert this to seconds. So 5 into 60 it will be. All right, so calculated, I think you'll get around 3 lakh if I'm not wrong. So if you multiply it, you'll get around 3 lakh. So that's around 3 lakh watt hour you'll get, because the unit is watt hour. Now that the commercial unit is kilowatt hour. So divided by 1000, you'll get it in kilowatt hour. So that'll be 0 gets cancelled, 0 gets cancelled, 0 gets cancelled. So that'll be 300. Sorry, did I make any mistake? All right, I think I made some mistake there. 1 second. Let me just check the calculation, guys. 1 second. Yeah, I think it'll be around 300 itself. So it'll be around 300 kilowatt hour, if I'm not wrong. Yeah, it'll be not kilowatt hours. Yeah, so kilowatt hour, you can also write as kilojoules. All right, so instead of kilowatt hour, I can write as kilojoules, because yes, it's energy. So I can write as kilojoules instead of kilowatt hour. So I'll just remove the watt hour. I'll write it as joules, just to avoid confusion. All right. All right, so I'll write it as joules, kilojoules. That's it. As simple as that, guys. So it'll be 300 kilojoules. That will be the answer for this question. Again, you'll study about this electrical energy towards the end of this this series. So we'll study about that as well. So don't worry about it. But right now, the answer to this question would be 300 kilojoules. So that's it, guys. That's it from my side. And this would be your homework for today. Like I told you guys, homework, whoever does it the faster and puts it down in the comment section below, I'll put their name in the next session as well. So if you want to show your name off, then definitely try out this question and then put it out in the comment section below. And otherwise also, please do this homework. It'll be a good practice for you people. So here's the question for today. How much charge can a potential difference of 10 volt move if it takes 5 joules to move charge from one point to another? So you have to find out what is Q. You have to find out the value of Q. Potential difference is given as 10 volt, and the work done is given as 5 joules to move from one point to the other. So you're supposed to find out Q. Once again, guys, direct substitution, rearrange the equation and get the answer for this one and put it down in the comment section below as soon as the video is out. All right, so that's it, people. Thank you for joining. Do share this if you liked it, and do like the video, and do subscribe to the channel as well, because we'll be coming up with more such content in the future as well. So thank you for spending your time with me. This is Anoop. Thank you. It's been a great time spending with you guys. And if in case you want to reach out to me, if there's any doubt that you want me to ask, You can reach out to me at anoop.manoharan@vedantu.com. So that is my personal email ID. You can send an email over there, and I'll try to answer it. All right. So thank you for joining, guys. See you in the next one. Take care of yourself. Stay safe, and bye bye. Thank you, people. All right. Then.